All right, welcome to day 4 trapezoids. If you're wondering what happened to the day 3 video, there was no day 3 video because day 3 was review and practice with parallelograms. So I didn't make a video for that. But we're moving on today. Day 4, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So I went ahead and marked that here in the picture for you. Those are the parallel sides. They are called the bases. So the parallel sides are called the bases of the trapezoid. And adjacent to the bases are the base angles. So for example, angle A and angle B here are one pair of base angles. Okay. The non-parallel sides are called legs. So if I want to name those, the legs would be AC and BD. Okay. Another thing you should be aware of is that because we have these parallel sides, we have same side interior angles here. Okay, so these consecutive interior angles between the bases, so where we have one angle with each base, so angle A and angle C, they will be supplementary. And angle B and angle D will also be supplementary. And supplementary means that they add to 180 degrees. Okay? A right trapezoid. A right trapezoid has two 90-degree angles. So if you're looking at this one, it would be these. And we can't have just one, could we? Because if this one is 90 and these two have to be supplementary, they're both going to be 90. Okay? So you can't have just one 90-degree angle in a trapezoid. It has to be two. All right. Isosceles trapezoids. If the legs of the trapezoid are congruent, then it is an isosceles trapezoid. So in this diagram here, I've got my parallel sides here, so my legs are these. If they are congruent, then it's isosceles. If that is the case, then the base angles, so here and here, they are going to be congruent. Remember how we had congruent angles in isosceles triangles? Well, we also have congruent pairs of angles in isosceles trapezoids. And also, the diagonals here will be congruent. So here's one diagonal and here's the other. Notice they do not bisect each other. That's something that happens in parallelograms. That does not happen in trapezoids. But the entire, if I name this ABCD, the entire diagonal AC is congruent to the entire diagonal BD. So the diagonals are congruent. Okay? So take a minute, pause it if you need to finish writing that, and I'm going to go on. So given that ABCD is a trapezoid, AD is perpendicular to DC. Remember that symbol? Perpendicular means that there's a 90-degree angle here. Ooh, here's a throwback. If the slope of AD is 1, so the slope here of this line, if I want to extend it and make it a line, is 1, what would be the slope of DC? I'm kind of jumping around here with the questions, but I want you to think about that. If this slope is 1, what would be the slope of a line perpendicular to that? Remember that perpendicular slopes? It's a good chance to throw in a little review here. Perpendicular slopes are opposite reciprocals. So what's the opposite reciprocal of 1? Well, the reciprocal of 1 is just 1, and opposite would be -1. Okay? The measure of angle DAB, well, let's look at that in the picture. DAB would be this angle up here, which would have to also be 90. Okay. Down here in question 3, if AD is perpendicular to DC, and the measure of angle ADB, so ADB would be this angle here, equals the measure of angle BDC, oh, sorry, it doesn't equal it, sorry. The measure of angle ADB is 2x minus 25, so that's here. And BD is x plus 10, that's here. How are we going to figure out the measure of angle, or the measure of x, value of x? Sorry, it's Friday afternoon. I shouldn't make videos on Friday afternoon. But these two angles, because this whole thing is 90, they have to add up to 90. So 2x minus 25 plus x plus 10 equals 90. So 3x minus 15 equals 90. And if I add 15 to both sides, 3x equals 105. Dividing both sides by 3, x equals 35. Okay? Pause it if you need to write that, and we're going to go on to the next page. So we're doing some practice solving here. So given that ABCD is an isosceles trapezoid, the measure of angle DAB is 130, so DAB is this whole thing here. It'd be a really good idea if you kind of pause the video, see if you can figure any of this stuff out before I do it for you. AC is 10, so that's this whole diagonal. We're told that this is an isosceles trapezoid. Did you guys see that in the directions there? That ABCD is an isosceles trapezoid. So we know two things. Well, really three. We know that these legs are equal. We know that these diagonals, so AC should equal BD, and that these base angles will be congruent to each other. So if this whole thing is 130, this whole thing is 130. Okay, so let's see if we can use that. Pause the video and try it. All right. AD is 5, so that means that BC is also 5. BD will be equal to AC, and we're told that AC is 10. Measure of angle ADC. And we remember that these consecutive angles between the bases, so it's one with this base up top and one with this base down here, they have to be supplementary. So if this one's 130, this one would be 50. 180 minus 130 is 50 degrees. Measure of angle BCD, so that's this angle over here. Well, these base angles have to be congruent, so that will also be 50. Okay. Then I also told you that the slope of AB is negative 1/3. So that means the slope of this segment here is negative 1/3. So what about the slope of DC? Well, this is a trapezoid, so those segments are parallel. What do we know about the slopes of parallel lines? They are the same, so this should be negative 1/3. Okay, number 9. PQRS is an isosceles trapezoid, and we've already marked those legs congruent. If you want to, you could also go ahead and mark that these angles are congruent and these angles are congruent, right? So really that kind of helps us figure it all out, because R is going to be 40, and then each pair of consecutive interior angles between the bases are really just same side interior angles between parallel lines. So they are supplementary. Okay? So pause the video and try these. I'm going to go over them, but I want you to pause the video and try them. If you haven't tried anything on your own yet, do it now. Okay, so this is 78, which means that this one has to be supplementary to it, which makes this 102. 132 and angle M need to be supplementary, so 180 minus 132, that's how I'm getting this, is 48. So I'll write that over here too. 180 minus 78 is how I'm getting 102. All right, for number 11, I have, okay, so I have 65 and R. Those will, the angle S and angle R are same side interior here. So that would be 180 minus 65, which is 115. And over here, same idea, 180 minus 88 is 92. For number 12, we're told it's an isosceles trapezoid, so that means that this angle over here is congruent to that one. And then again, we have supplementary pairs. So this should be 110, and this should be 110. All right, last but not least, these two down here where we're going to need to solve for x. EC and FD. What do we know about EC and FD? Those are the diagonals in this isosceles trapezoid, and we're not told it's isosceles trapezoid in words. We're told it by the markings. Because these legs are marked congruent, they will be isosceles. So they're equal. So 5x minus 10 should equal 20. And then I can solve. 5x equals 30, divide both sides by 5, and x equals 6. For number 14, these two angles are same side interior, right? Just like we were using up there, but now they both have x's in them. So that just means I need to make an equation. 10x minus 33 plus 4x plus 17 should equal 180. So 14x, negative 33 plus 17, I believe is negative 16. Equals 180. So let's add add 16 to 180, and that's 196. We're going to be dividing by 14, and that is 14. Okay. All right, if you need to pause it to get caught up, you can. I am just going to go ahead and fill this in and post it on Schoology, and I will try to include any additional information that might be helpful to you. But be sure if you have questions about any of these that you come and see me, okay? That's it.